Hi all, let us see problem solving in Doppler's effect. A source emitting sound of frequency 1000 Hz is moving with velocity 30 meter per second towards an observer. The velocity of sound in air is 330 meter per second. What is the frequency of sound heard by the observer? So the question is about source moving towards an observer. Where the observer is 0, it is moving towards, according to Doppler's effect formula, the numerator will be positive because it is approaching, and the denominator will be negative with the speed of observer is 0. So we substitute all the values accordingly in this formula. Then your apparent frequency is 1100 Hz. And followed by another questions, which is the frequency of sound is 1000 Hz. Source is moving away from a stationary observer with a velocity of 30 meter per second, and velocity of sound in air is 330 meter per second. What is the frequency of sound heard by the observer? Now we can see that source is moving away from a stationary observer. So if anything moving away, so the numerator will be negative, followed by the denominator will be positive. The observer is stationary, so the observer is stationary, the speed of the observer is stationary, and we substitute all the possible values accordingly in this formula. And now the apparent frequency is 917 Hz. By using the two values, which is the apparent frequency for the question 1 and the apparent frequency from the questions 2 about this, we can put these two values into one solid graph. We can have a look at this graph, which is when the source is approaching the observer, stationary observer. You can see that the apparent frequency 1100 Hz, and when the source is moving away, your apparent frequency is 917 Hz, where the frequency of the source or actual frequency is 1000 Hz for the graph apparent frequency against distance. Or you can put it in this way. It is almost same, only the shape of the graph is started from here. So that means the same thing goes for this graph, which is the apparent frequency when the source approaching is 1100 Hz, and when it is moving away, it is about 917 Hz for actual frequency 1000 Hz. So we can put these values into graphical method. Now we come to the final part of Doppler's effect. In this special case, we're going to see a car is traveling at 25 meter per second along a straight road when it is overtaken by a police petrol car traveling at 50 meter per second. If the frequency of the petrol car's siren is 1000 Hz, what is the frequency of the siren heard by the driver of the car when the petrol car is behind him? For A. And for the B, when the petrol car is in front of him, the speed of sound in air is 330 meter per second. In this case, we can see that the source and observer are moving simultaneously with speed of observer is 25 meter per second, speed of source is 50 meter per second, and speed of sound in air is 330 meter per second. For the section A, when the petrol car is behind him, the petrol car's siren is 1000 Hz, which is moving with a speed of 50 meter per second. It means the petrol car with the source is moving 50 meter per second. The source is the siren of that petrol car. So the source is behind the observer. The source is behind the observer because petrol car is behind him. So source is left behind. When source is left behind, the numerator will be negative and the denominator will be negative too. The source is petrol car is behind the observer. Both are moving. So this is going to be a formula with the numerator is negative, denominator is negative too. So substitute all the values accordingly into this formula and the apparent frequency is 1089 Hertz. For section B, when the petrol car is in front of him, now the source is hitting the observer. Source is hitting the observer. The numerator will be positive and the denominator will be positive too. Then you're going to get this formula and substitute all the possible values accordingly in this formula and the apparent frequency will be 934 Hertz. The special case in Doppler's effect is no more in PSPM syllabus. So I am sharing and giving extra input on this rote so-called Doppler's effect. Let us try to put these two values of apparent frequencies, which is 1089 Hertz and 934 Hertz, into one solid graph. The graph will be like this. When the source is approaching the stationary observer, the apparent frequency is 1089 Hertz. When it is moving away, the apparent frequency is 934 Hertz for apparent frequency against the distance. And you can put it in this manner without putting any banner. Same thing, when the source is approaching the stationary observer, the apparent frequency is 1089 Hertz. When it is moving away, the apparent frequency is 934 Hertz for apparent frequency against the distance. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.